Hello. In this video, we'll see the details of Kubernetes. Okay. Now look here. So before Kubernetes, containers were powerful, but operations were still manual. That means first Docker container came to the picture, right? Later Kubernetes came. So before Kubernetes, containers placed by hand on servers. But with Kubernetes, the workloads, right, places by the scheduler automatically. The next one is scripts, right? Restart and deploy the logic. Suppose one of your container is not working, right? So what you can do, you have to manually restart and deploy the logic. But here in Kubernetes, it is a self-healing approach. That means a restart failed pods automatically. The next one is as a traffic and microservice grew, manual operations became the bottleneck. Because just imagine if I have 100 plus microservices or 500 plus microservices, manually do the operations, it's very difficult task. That's why by help of the Kubernetes, right, we can easily manage it. Our operation task will be less. Now this is the overview. Kubernetes gives the industry a control plane for running applications at scale. So before containers placed by hand, in Kubernetes it is automatically placed by the scheduler. A restart and deploy logic automatically. If any application is failing, we have to restart the container manually. But here in the Kubernetes, it is a self-healing process. Dashboards, human watch traffic. But here in the stable access and discovery by using the Kubernetes service. Late night manual scale and recovery. Here it is a react to the traffic by a HPA. Now let me go to the next slide. Kubernetes is a software and it has many objects or components. If you want to run your application on Kubernetes, you should have understanding on these objects. One is called your pod, replica set, deployment, service, horizontal pod autoscaler, PDB, config map, secret and network policy. Now let me go to the next slide. Suppose, first of all, right, how you can run your application on Kubernetes. If you want to run your application on Kubernetes, you should know the pod. By the help of the pod, I can run the application on Kubernetes. So once it is run by the, then user can send the traffic to the applications. So you can see here my user, and initially I am sending 100 requests. Then the request will go to the Kubernetes service. Then Kubernetes service will redirect the traffic to the pod. Just imagine current load of my application or pod is 18% and 29%. Why we are using Kubernetes service? Because pod IPs can change at any time. If I restart this pod, automatically the IP will be changed. This IP I can't use or I can't share with my users. For that reason, I have to add a Kubernetes service so that that service will keep on monitoring the pod. If the pod is restarts or any IP is changing, automatically the service will take it. The next slide, this is the sample YAML format for the pod. I will see API version v1, kind is pod. I told already in the first slide, right? In the previous slide, you'll see there are many objects, Kubernetes objects. Then how the Kubernetes will know that user is going to create a pod or replica set or service map or config map or secrets? That you would specify in the kind. Kind is pod. Then you would specify the name of the pod that will be under the metadata session. Then you would specify the labels. This is very important, the labels, because if any other Kubernetes object is trying to communicate with your pod, then this service labels, right, that will be used. And there is another important parameter here, resources. In the resources, you can see that two blocks are there. One is called your request, another is called your limits. Request means this is your baseline. When your container will start or pod will start, then it will allocate 100 M CPU, 128 MI memory. Limit means it can go up to CPU allocation 250 M and memory is 256 MI. Now here you can see traffic starts moving. Now suppose I am sending 500 requests to my application. My application is running inside the pod. Just imagine current load is 47% CPU utilization and 42% memory utilization. In the next slide you can see here, if I am increasing the traffic from 500 to 800, now the CPU utilization and memory utilization became more. Now it is 72% and 69%. That means your CPU and memory are entering the danger zone in your pod. The next one is, if now I am sending 1200 requests per minute to that application. Now already CPU throttling will happen. That means other requests cannot be solved by my application that is running inside the pod. Then how to, and you can see here, there is only one pod. Pod means you can imagine it is like a baby computer. Okay, it is like a baby computer. Only one pod is running. The problem is if that pod having CPU or memory throttling, memory issue, right? Your application cannot be accessed. That means the users cannot access your application. Your request will be rejected. To solve this problem, okay, before going to the solution of this problem, right? So I'm just explaining little bit about the Kubernetes service. Suppose if you want to create a service, right, the kind should be service. Then if you see here, selector app viral web, right, this is called my application name, or you can say pod name. Where this is mentioned inside the, this is mentioned in the metadata name labels. Same app colon viral web, it should be added in the service, Kubernetes service. Okay, this is called my Kubernetes service. You can see same selector, in the service selector I have to specify the label of my pod. That means this service, what is the service name? Web-service. Now it is dedicated for that pod. Which pod? App colon viral web. Okay. Now user will send the request to load balancer. Load balancer will send the request to the Kubernetes service. Then it will go to the pod IP. Now look here. The first problem is what? Now I have only one single pod. Now it is request became more, CPU utilization is more, and memory utilization is more. How to avoid that problem, right? The problem is now I can't, if that pod is fails due to high CPU and memory, my application cannot be accessible. To avoid that problem, we can go a concept called a replica set. Instead of running a single pod, we can run a fleet of pods or group of pods. Replica set keeps the desired number of matching pods alive. That means here in the you can see, right, kind is replica set. That means I have to specify number of replicas. Number of replicas 3. 3 means this app colon viral web, right? This is called my pod. How many pods it will run? It will run 3 pods. And these 3 pods will be watched by the replica set. What is the replica set name? Metadata name, that is web replica set. If one pod dies, Kubernetes create another. What is the advantage of replica set? If I am deleting the one of the pod from this replica set, automatically the replica set will create one more. It will always maintain 3 pods. Also capacity improves because traffic can be shared. Now look here, previously my request was, now look here, previously my request was going to one of the pod, right? One pod. Now it is, my service will distribute the traffic to multiple pods. Even if I am sending 1200 requests, this 1200 request will be shared across pod 1, pod 2 or pod 3. And you can say this Kubernetes service is act as a load balancer. Now just imagine here CPU utilization is 58% and memory utilization is 55%. Now I am increasing the number of requests to 1600. Then it will hit to the service. Which service? This replica set service. Then now just imagine CPU is 88% and memory is 83%. Pod 1 is now hot because request is more. Pod 2 also problem. Pod 3 also problem. That means 3 replicas are not enough now. Fixed replica count is still is a guess. I don't know, right? How many replicas, whether it is 3 or 4 or 5 or 6, can solve my request. This is a guesswork. To solve the guesswork, there is a concept called HPA, horizontal pod autoscaler, came to the picture. Now what happens in the let matrix decide the scale. Horizontal pod autoscaler adjust replicas based on the observed demand. What I am mentioning, just look here. Clearly I am specifying here. Hey, create a horizontal pod autoscaler, and the name of the autoscaler is wave-HPA. And here this is the target value or threshold value I have given. What is the threshold value given? Average utilization is 60%. So, and also I have mentioned minimum 3, maximum 10. That means it will always maintain 3 replicas all the time. If my utilization, CPU utilization is more than 60%, then it will try to automatically, it will scale out the pod, or you can automatically, it will add the new pods to maintain the threshold value or to minimize the threshold value. Now just look here in the next slide. Now my same 1600 request, it is going to the service is sending the request. Now just imagine 91%, 86% utilization. HPA trigger, CPU is above 60% because my threshold is given here what? 60%, right? Hence HPA trigger because CPU is above 60%. Trigger means what it will do? It will add the new pods. Now look, automatically it will add the new pods. Now your CPU and memory utilization become less. This is the automatically, this is a horizontal pod autoscale. Automatically it will adjust it will automatically scale in, scale out the pods as per the load. We have to specify the utilization here in the HPA. Okay, this is the HPA configuration. You have to specify the utilization. You can also specify memory, CPU. Okay, the next, let me go to the PDB. PDB means HPA gives more pods. PDB protects availability during voluntary disruption. So during the cluster operation activities, right? Suppose you are doing the repaving your cluster and all. During that time, HPA, right? It will not make sure that all the time 3 replicas will run or 2 replicas will run. To make sure always some constant number of pods will be run all the time, we have to configure what is called pod disruption budget. So in PDB basically used during the node drain, cluster upgrades or maintenance time. It tells Kubernetes do not evict too many matching pods at once. Example, with 3 replicas, minimum available 2. That means at least 2 pods serving traffic at any moment of time. PDB is not auto scaling. It is availability protection during planned disruption. Next one is config map, right? Now look, suppose you designed your application. Now your application is running on the dev. Suppose just imagine your application is connecting with the database, dev database, development database. But same code will go to the higher environments, whether it can be UAT, prod, breakfast, whatever it is. But the problem is the databases are different. Each environment have different databases. I can't use dev database in UAT or prod. To do that, we have to use a concept called config map. That means the application dependency configs should be stored in the config map instead of hard-coded in the application code itself. So that what you can do, application code reads environment variables instead of hard-coded value. Same image can go to dev, QA, stage and prod with different configurations, application configurations. Okay, now you can see if you want to create a config map, the kind should be config map. The name is app-config. And here I am mentioning the database host, database name, S3 bucket, anything, whatever the application dependency you can add here. So that your application code, business code will be loosely coupled with your application configs. If I suppose just imagine one of my database got crashed, I have to create a new database. Again, if I have to change in my application code, again I have to redeploy. It is a time consuming process. Hence, if you are using config map, So what I will do, I will just mention the DB host. Once the new database is created, I will go to that config map, add the database host, restart the application. Quickly you can change the configs. Now, this is just an example how you can use the config map. Python app reads DB and S3. Look here. In my code itself, this is my right side, you can see that is my one sample Python code. In this code, if you see, there is nothing called hard-coded value, because everything will get from the config map, right? Whatever the config map it is holding, same value it will get here. I am not adding any hard-coded value in the application itself. Now go to the next slide. Credentials stay out of the code. Look here. Suppose whenever you are connecting to the database, right? The database password is a very sensitive data, right? You should not keep your sensitive data on the source code or container images or in Bitbucket, wherever it is, right? But it should be somewhere stored in the secretly. It is a secret data, right? It should be stored somewhere in the safe place. For that reason, Kubernetes is given a concept called secret. Okay, I'm going to create a secret, and this secret basically used for passwords, API keys, and access tokens. In production, pair Kubernetes secrets with a cloud secret manager. Okay, either you can use AWS secret manager and all, but if you do not want to use external services, then you can use Kubernetes secret manager object. The next part is, look here. Suppose when I have a Kubernetes cluster, my many microservices are running. When many microservices run together, not every pod should talk to every other pod, right? Ingress controls. So how you can do that? Suppose application 1, there is a connectivity from application 1 to application 2. Application 3 and 4, they do not have any link to application 1 and 2. So how you can control that? How you can make sure there is zero trust policy? That means if application 1, there should be a connectivity from application 1 to application 2. There should not be any connectivity from application 1 to application 3. We have to achieve that by the concept called network policy. In the network policy, we have to specify there are two things are there. One is called ingress, controls who can call this pod. Ingress means incoming traffic. Egress means outgoing traffic. That means suppose outgoing traffic, that means in egress controls where this pod can call out, that means outgoing traffic. This pod can call other pods, right? That is called egress. Example, frontend can call order API can call order DB and DNS. You can see here. Ingress, who can call this application? Frontend. And egress, it is clearly mentioned, app is order DB. That means this pod can communicate only app DB. Who can communicate this pod? Okay, application app frontend, right? This is the ingress and this is the outgress. Microservice need traffic rules, not a open network by default. Okay, this is about the Kubernetes objects. So in the next slide or next video, what we will see, the entire concept, right? We'll see practically by using AI. Okay, within 30 to 40 minutes or within 1 hour time duration, we'll implement entire concept by the help of AI. Thank you guys.